Hi everybody and welcome to today's webinar. The topic today is what's new in 3D Survey 2.9.0. So we are about to release the new version of our software. So official release date will hopefully and probably be around Thursday 13th of June. So that's 14 days from now. And today we will look at which new features are coming to our software solution. So let's go right ahead. So the first new feature is full support for RTK and PPK telemetry solutions. So we know that we have new Phantom RTK drone on market, which is now available for about 5,000 euros. With this new version, we upgraded our bundle adjustment and orientation algorithms to support the precise positioning information, which is available on Phantom for RTK drones. And we will use this to get higher accuracy data even without the use of ground control points. So let's have first some looks at some aerial images that we have right here. So if I just open one image, you will notice that with the new Phantom drone, the aerial images, they have considerably more radial distortion. So here you see, for example, a building edge that's straight in nature. On the photo, it's a little bit bent. So that's because the DJI did some changes to how they save images. Before, those images were automatically corrected for the biggest radial distortion. Now they leave it inside and they leave us to deal with it. So, and also the images themselves, they now carry more information than they had previously. So we know about EXIF information, which can be found here under details. So even here, now the GPS latitude and longitude, they are more accurate than in the case of regular Phantom 4 Pro. But the images themselves, they also carry more information. We can check that by opening aerial image in online XMP viewer. I have just uploaded the image up here. So now the images, they also contain absolute altitude and relative altitude information. And what's also important, they also contain calibration information. So they have calibrated focal lengths, and also in here they have some numbers that tell us how to undistort those images. So in 3D Survey, we now have support for this information. So when we open a project in 3D Survey, so I will just start from the beginning, go to images, load images, and let's try with this project. Open. For telemetry, we still set to EXIF data. We have to, now it's very important with the RTK to correctly set the coordinate systems, because if we set it wrong here, we won't get good results. Import. Data was successfully imported. Okay, close. So what is new? So here we now have camera properties icon. So here we now have the calibrated camera parameters, which are read automatically from the aerial images. Okay. So after this step, we would normally do the bundle adjustment. Let me just move to this project right here. So now this is a similar project that for which we have already completed bundle adjustment. Now the next step is orientation. Here in this project, we have some ground control point data. You see them here on the roof of this building. But for this project, we will now use ground control points for validation only. So 3Dsurvey now also supports this functionality. So we will go to orientate with ground control point data. Let's load in the ground control points. Now it's important to set this to non-projection so that the telemetry information is properly used. Import. And I will just load the GCP detections in. Okay. And what we will do now, instead of using these control points as GCPs, we will use them as validation points. So setting the known points to validation, that means they won't be used to georeference the model. They will only be used to check the accuracy of positioning. So now, in this case, only the telemetry information will be used to georeference the model. Let's go to the next step. So we already have the positions of all the ground control points marked. So in case we are using the RTK drone, because we now have a lot better positions of ground control points, software will also give us pretty good positions where the positions of the ground control points are. So let's go to the next step. So because I just loaded in the results, this is all good already. And now next. So now orientation is done on the telemetry information, and the errors that will be displayed here will only be used to check the accuracy of the data. So here we can now see what kind of accuracy we can expect if we worked this example without the ground control points. So here we see that we get a couple of centimeters of offset in X, Y, Z directions, but all in all, we get about 4 centimeter accuracy without using any ground control points and only using the ground control points for validation purposes. So, of course, if we used also ground control points to georeference this data, then the end result would be even more accurate. So we have a sort of a catch-22 situation. If we want to know what kind of accuracy we will get from the RTK drone, then we need to measure some points on the ground. If we don't, we may not know the accuracy of the 3D data. But if we do position them on the ground and measure them, then we will get better results if we use the ground control points. So if we don't just use them for assessing the accuracy of data. But this is something we can now expect from RTK drone. So even without the ground control points, we can get sort of good accuracy of generated results. So, and generally we will get better XY positioning than altitude. So all of our tests show that in Z we can expect slightly larger offsets than in XY direction. So okay, let us finish this one now. So now you see all the GCPs here, they are marked in gray, so that means they were only used to check the accuracy of the data, and they are also orange here in 3D view. So we think this is a pretty good result for some data that was obtained from satellite navigation system, but for highest accuracy, still use of ground control point data for georeferencing also will be recommended. But maybe for larger areas where 5 centimeter accuracy is enough, then we will also be able to work without the ground control point information. So and also with the RTK, to get this kind of accuracy, it helps a lot to have flying heights on multiple altitudes. So just like we have here, some photos recorded at 50 meters altitude and some at 80 meters. So this is maybe something that's better. This helps to get this kind of accuracy. We have similar results obtained also for the cases where we have only one flying height, but sometimes also for this kind of flight configuration for RTK drone, we can sometimes also get accuracy of 20 or 30 centimeters only when we don't use any ground control points. So in this case, it may help to add flights at multiple altitudes. So I can also show you how we can also check now the accuracy of generated data with less clicks. So now we also added two icons here. So with this first one, we can import the positions of ground control points. So this is an example from Turkey. Okay, important to set it now here to known projection, import, and so we should mark all these points to be validation points, not ground control points. So if we now want to check the accuracy, we can also import here the GCP detections. So this will now take a couple of seconds. So for the software to triangulate the positions of our checkpoints. Okay, this was now done. So if we just scroll here, so now the errors are about 1 meter. So that means that for now the positions of ground control points are still about 1 meter below the surface. Now what we just need, so these are just the triangulated positions of ground control points, but we still haven't done the orientation with telemetry. So now let's do that step. So now only do orientate with telemetry. So this is the telemetry information only that will be used for georeferencing. So now the software will perform orientation. Okay, so here we already have the values of offset x, y, z. So this is the difference between where we have positioning of first image in telemetry compared to where that position is in our 3D model. So we will see that we generally get about 2 to 3, 4 centimeters difference here. Finish. So that's the difference between the telemetry information, between where we have position from telemetry and where this is in our 3D model. And now, after georeferencing, this error fell to 5 or 6 centimeters. So the biggest error we have 6 centimeters. So that's 1 centimeter in X, 4 centimeters in Y, and 4 centimeters in Z direction. So again, this is the accuracy we can hope to achieve when without using ground control points. So again, here the ground control points are only used to check the accuracy of the generated data. So this was a quick introduction of the new RTK feature. So we will look into more details with all the specifics about the use of RTK drones in one of the later videos. So this one was just to show the basic functionality that's now coming to 3Dsurvey. So, okay, that was first example. And now let's just go to the next functionality. And the next functionality will be the bounding box rotation. Okay, the second new feature is bounding box rotation. So we had quite a few people asking us about this functionality. So now we have upgraded our bounding box feature so that we are also able to rotate it in 3 directions. So let's go right up to an example. So here I have an example of point cloud. So because sometimes we would just like to focus on one building or a small part of our area of interest. So now we can do it like this. Also, let's squeeze it a little bit in these directions. In order to rotate the bounding box, we just right click on one of the edges and we can just rotate it. So if we click on this one, we rotate it in the vertical axis. Here we will rotate it horizontally and also rotate it here. So with this functionality, we can then move the bounding box however we like in order to better be able to select what we are interested in. So now we can just focus on this part of the point cloud. And when we go to the cat functionality, we will have an easier work if we don't have all the points visible. So now this bounding box manipulation is a little bit easier. So at any point, if we want to get back to our original view, if we want to reset this bounding box, we can always still click reset view and we get the whole view back with the default bounding box position. So it's a nice small feature and the second on our list. So let's move to our third new feature, which is the ability to capture video animations. So I have a project opened here that we use a lot for these demonstrations. So now we have here a new recorder functionality. So it works so that we first set our project. So we will set display however we want it. So for my visualization, I will use the drape or the photo functionality, and I will also add the point cloud. So now we go to the recorder. So this one allows us to set our views. Maybe I will add first camera here like this. Press add camera. We move to the next position, maybe here, add another camera. And let's go here onto this side street, add camera here. And also let's add one like that. Maybe like so. Add camera. So we will see that software then generates this kind of a path. Okay, let's add another camera maybe up here. So you see we make this kind of a curve. Now let's run a preview. Okay, we didn't do it perfectly. We go a little below the surface. So maybe we should do it a little bit differently. Let's up a little. So will be better. So now we won't go below the surface. Okay. Make the video slightly longer so that we can better see what we want to show. Great. Now we just press record, save the file 3Dsurvey video demo, save some settings for the video, if we want to use watermark or not. For now I will leave it. And now the video is being generated. So and then in this way we have another way of how we can share 3D data with our clients. So we can make a video of the 3D data, which can then be sent via internet. So we have it now here. So this is the watermark. You can choose to include it or leave it out. So that's up to you. And now this enables us to do breathtaking videos, and we can show in the video whatever is shown here in our 3D view. Now let's move to the next feature, feature number 4. So that's improved CAT functionality. We have a project to show this upgraded feature here. So now under CAT tab, we have some new buttons here. So now when we zoom in on a part of a point cloud, so let's create a new layer, layer number 1, for example. Let's make it red like we usually do. Okay. So first new feature is when we are now drawing lines, we have some additional features. First one, I think that's very useful, is to add points on the vertex. So now the cat functionality also supports creation of points. Let's go here and let's start digitalizing this road feature. So you see that we have upgraded it slightly. So the lines now also get point information, so point number and also point altitude is displayed as a text. So what's new? So we can now choose what we want to snap to. So now we have snapping on point cloud points, endpoints. We can also choose to snap on midpoints or somewhere on the line. So we can also just select only this one. And now it will only snap on the line. So this way we would only be able to snap somewhere on a line that we have selected. Or we can choose only to snap on point cloud points. Alternatively, we can set it to snap only to the to endpoints of the lines, like that. So let's switch to new layer. We can draw lines like this now. So here, if we want to make sure, we can choose what we are snapping to. So this will now only enable us to snap to the points that were previously marked. Without a point on vertex, we can set it like this. Okay. So this was the draw line functionality. Another functionality that we have is now draw points tool. So similar to that one, we can also place points on the point cloud. Again, we can choose to snap to points. So the interpolate points option is now here. So this will now place a point on average height here. So we can also mark points like that. So here we can set it, we can set the point code to be, so how do we call this? Shecht. So switch cover, I'll just write cover and I'll place it here. So if we add the code information is also displayed and we can just quickly add those points like that. So this can now help us to more quickly mark some points in 3D. Okay. We can also choose to add some measurements. Maybe let's set to point snapper. So if we want to display in our results the width of the road, for example, like this, we can do also that. So this is now a measurement. And for measurements, we can choose to display 3D distance, 2D distance, slope, or delta height. So in this example, increasing the point render size will help us. Cat, we want to have point on top of the building and also one on the bottom. And we want to display delta height only. Okay, maybe to here. So in this case, now we have delta height of 8 meters. And we can also now we can also annotate now measurements in this way. So we can also annotate measurements in this way. Okay, let's decrease point render size a little bit. So the measurements, we can save what we have drawn into a DXF. So I'll just put it here, and I'll just write it example DXF. Press save. Okay. So double clicking on this one, we'll now open AutoCAD with this information. So let's just wait for it to load. Okay. So we just need to do the zoom extends. And this is the result we get. So now we can export this data, and we also get point number, point altitude, and the code in a text. So the code can be either a number or a word. And of course, they are put on separate layers so that certain information can be turned on or off. And now we can use this workflow to do a part of our survey map straight in 3Dsurvey and then just export it into, for example, AutoCAD or a similar solution. So alternatively, if we save the CAD information as a TXT file format, for example, TXT or KOO, so which are ASCII formats. In this case, we can also choose to save the point information. So now all the points that are used in this drawing will be saved as a TXT points. So we get now all the points. So we have point number 1, X, Y, Z positions. And for the points that have some code, we also get the code information. So in this way, we can also export the 3D positions of all the points. So it will be the endpoints for the polylines, also all the 3D points that we have currently enabled. So let's move ahead with our presentation. So a new feature coming to 3Dsurvey is also improved viewing options. We can show this right in this example. So we know that a lot of our customers are using laptops for viewing and working with 3Dsurvey. So in this case, pen functionality, when we need to click the middle mouse button and click and drag on the laptops, this may be a little bit hard to achieve. So to that end, we integrated a simple function where double click anywhere on the point cloud will zoom in to that position. So just like that, we can zoom in on point cloud, and if we need to zoom out, we just click reset view. So we can zoom in like this and then move the center of the point cloud anywhere we want. So for example, drawing a line, so digitalizing a house, just double click on that house, double click some more, zoom in on it, just go to CAD and start drawing like that. So now this can also be done if we don't have the full-fledged computer mouse attached. So also with just the laptop mouse, you can just use the double click to move the center of our view to that position. So a useful function that can help improve navigation of 3D data. Okay, this was feature number 4. Now let's move to the feature number 6, further improved dense point cloud reconstruction. So we have further upgraded the dense point cloud calculation algorithm with upgraded fusing part of the algorithm. So now the resulting point clouds will have even more detail. So here I have a nice example made out of some orbital images of a lighthouse in somewhere in the middle of Adriatic. Now, previously, this was the best quality of point cloud that we were able to get from this kind of images. So we have further upgraded the point cloud calculation algorithm, and now the results are even better. So from 5 million points on best settings, we went to 10, and the overall quality of the point cloud is now that the quality is even more detailed and the point cloud is even more accurate. So here we can clearly see the difference in point cloud quality. So the point cloud is now even more complete and even more sharp. So we actually ran a comparison with some competitive softwares, and we found that this quality, the old point cloud quality, is about the same quality that other softwares get, and this new quality that we get now is a step ahead. So at this point, we think that our software solution provides probably the best point clouds available. But don't believe me on my word. You can try it out yourself and see the difference. So also the point cloud calculation algorithm, we also upgraded some memory consumption and these kind of things. So now the best point clouds can be calculated even with any kind of NVIDIA graphics. So as long as we have an NVIDIA graphics card, we can produce this kind of a result, and it no longer matters how much memory this GPU has. So on slower GPUs, the calculation will take longer. Faster the GPU, faster we get to the result, which is now even more accurate and more detailed. So this was it for today's presentation, and now we will move to questions to see what, if you have any questions, we will also answer them here live. So, okay, if anyone has any question, please write them now here in the chat section. So, Jan, thank you for your recommendation, for your nice words. We also think it's a big step ahead. So we took a little bit longer with this update, but we think now it will be worth it. So thank you, Zoltan, for those starts. Can so JK Lim, yeah, I can send you the Word file with those
Everybody.
with those texts. So yeah, hopefully the update will be available for download in 14 days. If not in 14 days, then in 3 weeks tops. So now we are starting with the debugging of the software, and because we have changed a lot of things inside of the software, we also have a lot of debugging to do. Unfortunately, with the software is when you change something, it's you make a lot of problems for yourself. So at this moment, our developers are working hard on the debugging and testing of this solution. So thank you, Savisha, for your kind words also, and thanks to David Atkinson. Uh, so David Atkinson asks if we have any plans to add 3D mouse devices like 3D connection. At this time, we haven't considered it yet. So I'm not really sure. I think that if you connect a 3D connection to the software, I think there is an option to set it up. Maybe we need to buy it and try it and see how we can get it to work. So I'm not sure. David, if you have 3D mouse, we can help you. We can try to help you to set it up and to see if it works without any modification. If modifications will be necessary, then we can consider doing that with one of the next updates. So now the main development of the 2.9 version is complete. So we are also already working on the next version. We haven't decided yet whether we will call it 2.10 or 3.0, but we already know some exciting features that are coming to that version. So with 3.0 or 2.10, we will also add full 3D texturized mesh support. So we have the meshing algorithm 19%, 90% complete already. And so we're confident that maybe 2 months after this version, our next update will also come. So that the next update will be a bit faster than the one that we did now when it took us about 5 months or something like that to release the update. So we hope the next one we will be able to get it through faster. So, okay. So I think these were all the questions. So I would like to thank you all for listening to this presentation, and looking forward to see you on the next webinars. Bye bye for now.